one last example of being able to solve the system of differentials by using a Laplace transform. We have our x double prime plus 3x plus y prime equals 1, x prime minus x plus y prime minus y equals e to the t. So let's go ahead, and it probably looks like elimination might be an easier way to be able to solve this. However, let's go through and try to use the Laplace transforms for this. So we're just going to hit everything with the Laplace transform. So we're going to have Laplace of x prime plus 3 Laplace of x plus Laplace of y prime equals Laplace of 1. And then we're going to have another Laplace of x prime minus Laplace of x plus Laplace of y prime minus Laplace of y is going to be equal to the Laplace of e to the t. And at this point we can just go ahead, we can use all of our Laplace rules, Laplace of the derivative, Laplace of 1, and we could go ahead and maybe simplify this just a little bit. So we're going to have s Laplace of x minus x at 0 plus 3 Laplace of x plus s Laplace of y minus y at 0, and Laplace of 1 is going to be 1 over s. Now for our second equation, when we take the Laplace, we're going to get another s L of x, so s Laplace of x minus x at 0 minus Laplace of x, nothing we can do about that. We get another s Ly minus y at 0 minus another Ly, and the Laplace of e to the t, either by using the translation theorem or just looking it up directly in our table, is going to be 1 over s minus 1. Alright, so now what we're going to do is simplify. Some good news, any x or y at 0, those are all going to just go away, because remember we said x at 0 was 0 and y at 0 was 0. Alright, so that's helpful. And then in the first equation, I'm going to factor out an Lx from those two terms. In the second equation, I'm going to factor out an Lx where I can, but I'm also going to factor out an Ly where I can. Right? And so that way we can go through and maybe have a shot at solving in terms of either Lx or Ly. All right, so by factorization, we're going to get s, L, or not s yet because we're factoring, so we're just going to have L of x times s plus 3. We still have the s L y, and that's going to be equal to 1 over s. So that's not too terrible. The second equation, we're going to factor out an L of x, and that's going to yield an s minus 1. So we have an s, and then we have just a 1 here, but it's a negative. All right, so there's 1 L of x, so that's going to be s minus 1. Factoring out an Ly, that's going to leave us with s minus 1 again. So that's kind of nice that we have those two factors. And on the right-hand side, we have 1 over s minus 1. All right. Now let's just number these equations. Let's call this equation 1, and let's call this equation 2 just for our reference. And let's solve equation 1 in terms of L of x, all right, or just solve it for L of x. So if we do that, we're going to subtract the SLY, and then we're going to divide by s plus 3 to be able to solve for L of x. Or we could actually solve it for Ly. It might be a little bit easier. So let's do that. Let's solve it for Ly. It doesn't really matter which one, because eventually you can get to the answer. However, just out of convenience, because Ly is a little bit more simple. So solving for Ly in equation 1, that's going to be equal to, so we have the 1 over s, and then we're going to subtract, so this is going to be SLY 1 over s minus LX of s plus 3 But then we're going to divide everything by the s that's as a coefficient here. All right, so let's divide that out. And if we do that, that means that this is going to become s squared. And then over here, we get s over s and 3 over s, which is just 1 plus 3 over s. So we'll just condense that just a little bit. So 1 plus 3 over s. All right. Now that we have Ly, what we're going to do is we're going to substitute Ly back into this second equation. And hopefully we can be able to yield some sort of easy expression for Lx, because then we can go ahead and solve for Lx by getting the inverse. Okay, so we're going to plug Ly into equation 2. All right. Now that's not going to be too pretty, so bear with me on this. All right. So we're going to get L of x, s minus 1, and then we're going to substitute for Ly, and I'm going to do that in orange so that way we can see what's going on with this. So that's going to be the quantity of 1 over s squared minus L of x 1 plus 3 over s. And we still have to multiply that by the s minus 1 that was left over, or that was there to begin with. And that's going to be equal to 1 over s minus 1. All right, now, it looks really ugly, and it is, but there is a little bit of good news. The good news is that when we solve for L of x, it's probably not going to turn out too bad because we can divide everything by this s minus 1. So notice that there's an s minus 1 in both of the factors on the left-hand side. So let's divide by s minus 1, and that's going to give us Lx plus 1 over s squared minus Lx times 1 plus 3 over s, and that's going to be equal to 1 over s minus 1 squared, since we divided both sides. Right? We could subtract out this 1 minus s, or 1 over s squared, excuse me, and then we can also factor out the L of x from these two terms. So we're getting close to solving for Lx, so let's do that. So Lx, being factored out of this term and this term, is going to be L of x. There's 1. Notice that there's a negative here, so we have to distribute the negative to those two terms. Minus 1 minus 3 over s equals 1 over s minus 1 squared minus 1 over s squared. All right, and that looks kind of ugly. The good news is this just simplifies, and then we can multiply both sides by negative 3 over s to kind of clean that up and solve for our L of x. So L of x, unfortunately, at least initially, is going to be equal to 1 over s minus 1 squared minus 1 over s squared times negative s over 3. So we divided both sides by negative 3 over s, which is really by multiplying by s over 3 negative. All right, so what do we do with this? Well, we want to find the inverse, but unfortunately, it's not really looking like a good inverse at this point. So what we're going to do is we're going to do some algebra magic, and we're going to add these fractions together. Because that way we might be able to do a decomposition. And it doesn't make much sense, does it? Then we're going to add the fractions, and then what we're going to do is we're going to be able to decompose them. But in this case, it's probably going to make it a little bit easier. All right, so let's go through, and what I'm going to do is I'm going to maybe distribute the s to the numerators, and then we can get like a common denominator or something like that. So L of x is going to be equal to, let's just put the negative 1/3 out front. We'll deal with that later. So we get s over s minus 1 squared And then, unfortunately, we really can't do too much with that unless we were to do some sort of algebra magic, some real algebra magic, minus s over s squared. And that actually works out not so bad, because now we can go ahead and we can just say L of x is going to be equal to minus 1/3, getting a common denominator. Now notice s over s squared just turns into 1 over s, so that makes it really nice and easy. Common denominator is going to be s over s minus 1 squared. So we're going to multiply this s by the s here, so we're going to get s squared minus, we're going to multiply by s minus 1 squared. So we're basically cross multiplying there. And our common denominator is going to be s minus 1 squared. Alright, so looks pretty ugly at this point, but the good news is once we FOIL it out, it's probably not going to be all that bad. Alright, so mercifully, let's see what we can get out of this. L of x is going to be, we still have that negative 1/3 kind of hanging around there. S squared, when we FOIL this out, we're going to get minus s squared plus 2s minus 1. Alright. Now usually it's s squared minus 2s minus 1, but this negative gets distributed to all three terms. Alright, so we have to be cognizant of that. S minus 1 squared. S squares cancel out. And we can now write this in one of two ways. We can write this as L of x is equal to the negative 1/3 of what we have there. Or we could just go through and distribute the negative in the 3. And let's do that. So now it's going to end up being 1 minus 2s by distributing the negative, 3s, s minus 1 squared. Alright, so we'll stop the video here, and what we'll do in the next part is we'll find the inverse transform, so that way we can solve for x, and then what we can do is we can solve for y from there.